Hello and welcome. My name is Debasish Roy. I'm the Senior Network Analyst at the Indian Cybersecurity Solutions. And today we are going to learn about a very interesting topic of CCNA as well as CCNP, that is wireless networking. So let's begin. Now, we will discuss about this wireless access points, that is AP. But first, let's begin why to use these wireless networks. Because we were familiar with the WAD networks, right? Like the CAT cables, CAT5, CAT6, all these cables and fiber optic cables. But yes, the WAD networks have some disadvantages. Like, say, they have some distance issues. Like in CAT5 or CAT6 cables, it can go up to certain distance, let's say 100 meters or so. And beyond that, the distance limitation is there. And also, you need to procure those cables, to buy those cables, so the cost can be an issue. And maintenance of those cables is also a challenge for us. Also, you need a very huge space for installing those cables and say racks, closets there. So to avoid this, we can go for wireless networking. So that was the point when we moved from this wired network to the wireless networking. And to make a wireless network, you can have these devices. These are called wireless access points or APs. These are nothing but Wi-Fi routers. If you go to market or to any online portal, say you go to Amazon and you want to buy the wireless access points, you can do this. And you can see the Cisco wireless points are there, different types of devices there. They are known as hotspots as well. You can also plug in this wireless Wi-Fi routers or hotspots at your home, and you can share the internet. But there is a misconception that wireless networking is used for only internet sharing, but that is not true, because you can actually access any devices, any PCs through wireless network. Yes, you can share the internet access as well as you can communicate between the devices, say between the desktops as well, if you install the wireless network adapter card, and also laptops, because laptops or tablets or in smartphones, they are by default wireless enabled. So in short, this is the wireless access points you have, and you can see that they have different antennas also, and the frequency dependent on the how many wireless channels you have. So if you have two antennas, you have two channels, and if you have four antennas also, you can find many wireless access points. So they are having more channels, so you are getting more bandwidth and more frequencies. Now, let's talk about the wireless access point types. So, is there only one access point? No. Mainly, there are two types of access points according to the functioning. Well, if you have only one access point in your wireless network, it is known as the basic service set or the BSS. And if you're having more than one access point, say you are having like this one, these two APs, because see, if you want to increase your network, because your network is always scalable, right? So if you are going to divide the network into two subnets, or if you want to increase the network in the same subnet also by Wi-Fi extenders, you can use different APs. Say all the APs belong to the same provider. So in that case, if you're having two or more APs in your Wi-Fi network, then it is known as extended service set or ESS. But that is according to the number of access points. But according to the functioning, there are two also. One is autonomous access point and the other is a lightweight access point. So let's discuss what is this autonomous access point. Now you can see that this autonomous access point is connected to two APs and SSID. What is SSID? That is service set identifier. So it is the name of the wireless network actually, because security is very important, because if you are setting up a wireless network and you are not giving any SSID or any secret key, in that case, what will happen? Then anybody can access your network, anybody can eavesdrop in your network with a network analyzer or something like that, and you can be attacked. Okay, your wireless network is very attack prone. So in that case, you have to set up a particular SSID and also secret key for that. Because yes, wireless networking has some security issues previously, because in older times the encryption protocols were very weak, like the pre-shared key or the TKIP, temporal key integrity protocol. So these protocols were very weak. Nowadays we have the more secure protocols like wireless protected access, WPA 1, then came WPA 2, and now it is WPA 3, authentication and encryption. Previously, it was only WEP, WAD equivalent privacy, and that I told you the pre-shared key, that is TKIP, that was very vulnerable. So nowadays, the security is more in the wireless networks, but it generally grew. So you have to secure your wireless networks from outside attackers. Now let's come to this again. So you have this SSID stuff, and you can see that it is connected to the same subnet 192.168.100.0, and it is divided into two parts. So we have extended this wireless network with this AP, that is autonomous access point, and you have a client piece there in one of the cells. And you have the AP1 association that is associated with client 1. AP2 is not associated with clients now, but it will be associated later. But what is the job of this autonomous access point? Only to give the connectivity? No, it gives the authentication. It serves the authentication request from the client. So you can see that client is going to access the wireless network. Now the AP or the access point is connected all the way up to the switch. You can see the switch up there. Now the AP is there to authenticate the client request. So what is the authentication? That SSID and secret key or password. If you are going to connect to any wireless network, you have to click on that. You can see a list of the wireless networks, and say from that you select a wireless network, say it is Cisco or something like that. You click on that and you have to give the secret key. So who will authenticate? This autonomous access point is there for authentication. Also, it has some other jobs also, like QS policy or bandwidth setting, but main job is authentication. That is the autonomous access point that we have. After that, we have the LWAP, or the lightweight access point. Now, what is this lightweight? Now, the term itself tells you that the job is light. That is why it is lightweight. Means what? Lightweight access point is only giving you access to the wireless network. It only transmits the wireless signal, the Wi-Fi, the radio frequency signals, but it doesn't have any role in authentication. So you can see that in this figure, you have these two laptops accessing the LWAP with SSID, that is Wi-Fi VLAN 20. It is actually connected to different VLANs also, one to VLAN 20 and the other to VLAN 30. And you can see a CAPWAP tunnel is all the way up to the WLC, that is wireless LAN controller. And wireless LAN controller is someone who manages all these access points. If you are having more than one access points, more than one lightweight APs, here you do not have the autonomous APs anymore, because nowadays we do not use autonomous APs anymore. We use lightweight APs, because autonomous APs job is taken by the WLC, the wireless LAN controller. And CAPWAP is like the, you can say, a tunnel, just like the VPN tunnel. That is, it is not the VPN tunnel, but it is like that. Control and provisioning of wireless access points. That is the protocol for building up this tunnel. So what happens that LWAP forwards authentication requests all the way up to the WLC. And you can see the WLC is connected to the core part, that is the core layer of the Cisco 3-layer architecture, core layer, that is service provider L3 switch, and it has a trunk link for VLAN 10, 20, and 30. So all the VLANs are mapped to this LWAP as well to the WLC. And you have the distribution layer for the high speed traffic transfer, also ACL, any firewall rules, they are implemented there. And access layer is there for access layer, means to connect to the lightweight AP or to your stations. So this is a 3-way architecture of Cisco that we say. And that is LWAP, that is replacing the autonomous AP. So here you can see better about the wireless LAN controller that you have. And so this is the same thing that two users, Rick and Donald, are not supposed to access this wireless LAN controller and the wireless network as a whole. So this LWAP, ABCDs, they're all lightweight APs. They are forwarding the request to the wireless LAN controller, but they are not authenticated by the wireless LAN controller. And only the SAM, say that is he's an administrator or he's an authenticated user, he can only connect to this network. So everything is controlled by the wireless LAN controller. So this is the way you can set up a Cisco wireless topology. So this is about the theory part of this wireless networking, and we can actually build and secure wireless network using the Cisco packet tracer. So I'm now presenting the Cisco packet tracer with the wireless networking, and here you can see that if you go to this wireless devices, inside this network devices, go to the wireless devices and you can find many wireless devices from there. This is wireless LAN controller. This is packet tracer's default LAN controller, but I'm not using that. I can use either 2504 or 3504 wireless LAN controller. So I'm going with the 3504 because it is the latest in the packet tracer. So drag this wireless LAN controller there and you take a switch also. In this case, I am taking a 2960 series Cisco Catalyst switch. And you connect this switch to this wireless LAN controller and using a straight cable to any of the interfaces. So you can see the interfaces coming up. And here also, you can set up other devices. I am taking a PC to actually configure the basic configuration of the wireless LAN controller. So you connect a PC to it, 24, and now you go to the PC and give an IP address, say 10.0.0.1 or any IP you like, and also go to the wireless LAN controller, go to the config and go to management. You can see that already an IP is there, 192.168.1.1 and a subnet mask for 240. But I will change it here. Say this is 10.0.0.100 and the default mask. Now you can set up this wireless LAN controller here and you click on this PC, go to the web browser, click on the web browser, the browser will open, it will take some time, the packet tracer, and you connect with the HTTP. You at least need not to write this HTTP also, you just go to the IP, 10.0.0, I think the IP is 100. So you get that and press enter. It will take 1 minute or so to connect to the WLC and an interface should come, but it takes a bit time in packet tracer. Yes, it has come. So this is the Cisco 3500 series wireless LAN controller interface, and you have to create an admin account to actually use this. So it is prompting you to create an admin username. You can give administrator, admin, anything. You say admin and say give and password, say Cisco @129. And let's start. Yes. Now it's prompting you to give a system name. It is not the SSID. It is just the system name for this wireless LAN controller. You give any name. Say we say SS1. And also it is time zone. It is optional. Management IP address. You give the same IP. And the subnet mask, default gateway, you have to set a default gateway, and you give the default gateway as the PC's IP 10.0.0.1. And now you can set up the employee network or the management network. Here you have to give the SSID. Now you give a network name. Say the network name I'm giving as CCNA. Now this is a security. It's very important that you have to set up the security parameters here. Now you can set up the WPA to personal or WPA to enterprise. Now, what is the difference? In case of WPA to enterprise, you have to set up an authentication server or the AAA server. So the AAA server is something that you want to forward the authentication request to the AAA server, and it will do the authentication, not the wireless LAN controller. But we are not doing it here. So we are keeping it as WPA to personal so that only the wireless LAN controller does the authentication. And you give the passphrase also. Say,
Sorry to interrupt, sir. Actually, your screen is not visible. If you kindly share it, sir. Your screen sharing is not on, I think.
so we're doing this wireless LAN controller configuration, and here we are there. We just connected to this wireless LAN controller, and this was the interface. And you confirm the passphrase. You give a passphrase to connect, and you do not need to give any management VLAN because we are not going to map this VLAN because in packet tracer there is only limited capability. Click next. RF parameter optimization we are not going to do, and it is showing you to confirm the settings and apply. You apply the settings, click on OK, and yes, it will reboot. But there is a problem, the packet tracer bug problem, that it keeps on rebooting. So even if you fast forward that, it doesn't stop. So you have to manually stop it. Actually, it has rebooted, but you have to stop it. And you have to again go to the web browser. And this time you connect it with HTTPS. Why? Because if you connect to HTTP, it will again ask you for that admin account. Now it is prompting you to log in. Click on login. Yes, I'm presenting with the wireless LAN controller dashboard. So there you can see the controller summary, the management IP address, software version, everything, and also how many channels you have. You have the 802.11a, 11g, all these channels you have, and it's showing you the rough access points, means unauthorized access points. It's not detecting anything, but it is showing you the simulated interface here, and you can see the access point, the radio channels, the frequencies there that it is supporting. So it's not actually showing you anything but a demo thing. Now you can actually go to the WLAN, and you can see that we have created one, this CCNA, this network, and it is enabled. And you can also create a new network. Also, you can click on go, and you can actually create a new network from here. But here I'm not doing it for now, but because we have already created one. So you cannot actually do much. You can go to the security, and you can see that all things are disabled here. So not much there. You can only go to the WLAN, and you can only check this WLAN, these things, and you can check the security policy, that whether the pre-shared key WPA2 policy and encryption AES is enabled there, and the pre-shared key that we have connected, given here. So that you can check, but not much you can do in Cisco Packet Tracer. So again, what you can do, you can go to the wireless devices, and you can take an access point, say this one access point, you can connect this access point to the switch, and you click on this access point. Go to config, go to port settings, and you can see here it is giving you SSID option. So here in the SSID, you give the SSID that we gave, that is CCNA, that the network, and you give the authentication, that is the WPA2 pre-shared key, because there we selected the WPA2, and PSK passphrase, say Cisco @129. And so it's connected to the wireless LAN controller. One more we can do, we can go to the end device, and we can select any tablet or any smartphone. Say any smartphone I have taken, and you can go to that smartphone settings. You can go to config. You can go to the wireless 0 network, and if you have set up the DHCP server, it will take the IP address from the DHCP server. Right now it's taking from the APIPA range, but anyway, I'm not going to set up that right now. I'm only giving this SSID. You again change it to CCNA, and authentication WPA2 PSK passphrase that you gave as same thing, Cisco @129. So can you see that it has built a connection to the access point? So the smartphone or any tablet or any wireless device now connects to this wireless access point, and it is an autonomous AP in this case, but you can take an LWAP also, and so any access point will actually forward your authentication request to the wireless LAN controller. So before it's connected to the wireless network CCNA, the authentication will be done by this wireless LAN controller. So this security purpose is very important, that you understand the security purpose of this wireless networking, that you have to set up the correct pre-shared key format, or you have to set up the WPA2 authentication. If you are using any AAA server, then we have to go for the WPA2 enterprise. Otherwise, you have to do the WPA2 personal. So these are very important parameters for setting up this wireless network. So this is a wireless topology that we can build with the Cisco Packet Tracer. So I have discussed many things about the wireless networking, about the theory part, about the AP, about the WLC, and also I've shown you the practical. So I hope that it was clear to you, and I hope it was very beneficial for you about this wireless networking, and I hope that you have got a huge knowledge about this wireless networking from this. So that is it for now about the wireless networking, and I will come up with some new topic next day. Till then, it's bye.